Assalamualaikum and good morning. My name is NURUL binti Abdullah. Number matrix 231292908. So today I will present about voltage and undervoltage. For the introduction, voltage is short duration drops in RMS voltage between 10% and 90% of nominal, lasting 0.5 cycle to 1 minute. Typically caused by sudden load changes or fault in the power system. For the undervoltage, it's a long-term reduction in voltage, staying below 90% of nominal for more than 1 minute. Commonly results from overload system or poor voltage regulations.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL binti ABDULLAH. My matrix number is 231292916. Today I will be explaining the characteristic for this slide. We have two characteristics of voltage and undervoltage. But the first one, voltage, the duration for voltage, it lasts from 0.5 cycle to 1 minute with a sudden drop in the voltage. The magnitude of the voltage drop from 10% to 90% of the nominal level may affect one or more phases. Meanwhile, for undervoltage characteristic, a sustained voltage drop lasting longer than 1 minute, and the magnitude for undervoltage is smaller but steady drop, typically below 90% of nominal, shown in ITIC/CBEMA curve.
Good morning, Madam Amy. My name is Shangirti Chandrasekharan and my matrix number is 231293736. For today, causes of voltage sag will be my part. Okay, voltage sag, also known as voltage dip, short duration reduction in voltage level in an electrical power supply system. Understanding the causes in a key managing and mitigating this issue. Let's go through each cause. First of all, the first cause be motor starting, especially large induction motor. When a large induction motor draw a very high inrush current up to 6 to 8 times their full load current. Secondly, the sudden demand cause a temporary drop in voltage, particularly a weak and heavy loaded power systems. Common in industrial setting where machinery in a frequent started. The second one is short circuit faults. Electrical faults such as line to line, line to ground and three-phase fault result in sudden drop in voltage. This fault create a large current surge that disrupt the voltage profile in the system. Protective device like breakers may act, but voltage sag usually occurs. This device isolate the faults. The third one is transformer energizing. Energizing a transformer causes an inrush of magnetizing current, especially if it's large and cold. This inrush can result in a voltage drop in the nearby electrical network. Often seen when bringing transformer online during maintenance or system installation. The number 4 will be lightning strike and grid disturbance. Natural events like lightning strike can induce fault and create voltage imbalance on transmission and distribution line. Grid distribution, such as sudden changes in load or switching operation, can also lead to temporary sag. The number 5 is under voltage condition occurs when the power supply consistently delivers lower voltage and required level. Causes include overloaded system, poor generation capacity, and transmission constraint. Unlike sag, under voltage in longer in duration but may still be categorized depending on system standard. And the number 6 is overloaded power system. When demanded exceeded supply or the system are not properly balanced, voltage drops occur. Common during peak loads hours when the system is depressed. Stress can lead to widespread voltage sag across network. And the next one is weak utility supply during peak loads. During peak demands, utility might not be able to supply enough power to every consumer at nominal voltage. This result is systematic voltage sag, especially in regions with aging infrastructure or limited general capacity. By understanding these causes, engineer and technician can implement target mitigation strategies such as installing voltage regulator and upgrading infrastructure and ensuring proper load management to minimize impact voltage sag. Thank you.
Hello, my name is Mitran and I'll be talking about the effects. So voltage disturbance in a power supply, particularly there are two, which are voltage sag and also under voltage, and these both can have serious and sometimes hidden consequences in electrical system. So during a voltage sag, where voltage briefly dips between 10 to 90% of nominal for less than a minute, sensitive equipments such as computers, medical devices, they often malfunction or shut down unexpectedly. And in industrial settings, essential automation components such as PLCs, relays, and also contactors may trip without warning. Abruptly, it may halt the production line, and this can cause data loss, and also it is very time consuming. So the unexpected nature of these disruptions can lead to costly operational delays and also potential safety risk. On the other hand, under voltage represents a prolonged reduction in voltage because this is typically below 90% for over a minute. So motors which are operating under such condition often struggle to run ineffectively, or it can also stall, and this can cause the performance to diminish, and also the motor can draw excess current. So this increased current flow generates extra heat, particularly in the transformers and also cables, which may accelerate the insulation of degradation and also equipment wear. So over time, this induced stress may shorten the component's lifespan and escalate the maintenance cost. Additionally, the systems operating under voltage conditions, they tend to consume more energy, further inflating the operational expenses. While under voltage may not produce the dramatic shutdowns of a sag, its persistent nature makes it a stealthy and also more expensive threat to the production line. Thank you. That's all from me.
Good day to the lecturer, Madam Ami NURUL NAZIFAH. So, my name is Kavindraj, son of Nandakumaran. My matrix number is 23129226. And actually, this is topic to give as a peer-to-peer review, which is voltage sags and under voltage. as our group get this title. So my part of doing this is techniques, which is mitigation techniques. So there are 4 for each. So the first one is for the voltage sags. We use a dynamic voltage restorers, which is we use a dynamic voltage restorer, means we retrieve the voltage again. It's called as a DVRS. The second one is installing UPS system for critical loads. So we install utility power sources system for critical loads, for the heavy loads. The third one is fault current limiters network. So we need to put a limiter for the fault current to detect the network errors. The last one is reconfiguration. We need to reconfiguration the system or the power sources. For the under voltage, the first one is step changing transformers and voltage regulators. So this is when we handling under voltage, this voltage regulators and the transformers will help to balance the voltage counts. The second one is capacitor banks for reactive power compensation. So it's a alternative way to keep the reactive power. So we can get the sources for the as a second source. The third one is load shedding during peak demand. So load shedding as a peak demand means we shed the loads which is critical loads or any type like a non-critical sensitive loads for the peak demand situations. And the last one is upgrading undersized transformers and feeders. So when we upgrade the undersized transformer and feeders, it will provide more voltages and less currents, which is more sufficient for the signal or the networking systems. So that's all from me. Thank you, madam.
Hello everyone. Good morning. I'm Satish Medisami from RY31. My matrix number is 231-291-260. So today I'm going to explain my part, which is conclusion for voltage sags. Okay. We go to our conclusion. So based on our conclusion in this case, in this voltage sags, so under voltage condition can significantly disrupt the performance of electrical system and also electrical equipments. So for the voltage sags, through the brief often causes a sensitive device such as programmable logic controller, which is we call as PLC in our study systems, then relays and contactors to trip or shut down unexpectedly, which is leading to process interruptions and equipment resets. So on the other hand, under voltage presents a longer term issue where motors may stall or operate inefficiently due to inadequate voltage supply. This not actually reduce the energy efficient, but also leads to excessive heating in transformers, in our cables, or ultimately shortening the lifespan of our electrical component or system and increasing the maintenance cost of electrical system or electrical equipment. So that's all from us for the voltage sags calculation. Yeah, thank you very much.